Hey guys, welcome to another edition of Toolbox Tuesday. Today we want to take a look at finding the common start and run terminals on our compressor. Now a lot of times, if you'll notice, this 3-prong plug right here will have a cap on it. If it were in our system, we could pull that cap off, and a lot of times we can see C, S, and R common start and run inside of that cap. But I want to show you how to do it with your meter. Now this is one that we use in the lab for testing purposes, so you'll see some different numbers, but it should get us to where we can make an accurate reading and get the numbers and find out which ones are common start and run. Question you may ask is, why do we want to know that? Well, it can help us pinpoint issues that we may have in the compressor, be it an open run winding, an open start winding, a trip thermal overload, or our compressor could be shorted to ground. Just being able to identify that makes us a little bit more accurate than just saying, oh, it's a bad compressor. At the end of the day, you know, that's what the homeowner is most concerned about. Is it working or is it not working? But as technicians, I believe we have a responsibility to be as accurate as we possibly can in our diagnosis. So just want to kind of go over that and show you a little bit about how we do that. So the very first thing is, of course, our system is de-energized. Whenever we're checking anything in ohms, we want the system to be de-energized. So we're going to take our meter there. We'll have it set to ohms, and I always just draw these 3 little dots out on a sheet of paper. Now, most of you have probably done something like that, the inside of a capacitor box or notepad or whatever you have there, just something where you can kind of keep it all together. So on a sheet of paper, I'll just draw 3 little dots right there, and then I'm going to take some readings. So I'll place the meter over here so you can see it a little bit better. So we've got it set to ohms, and you'll see those numbers kind of jump a little bit, but it'll get us where we want. So if we go right there, we're getting 3.1, 3.0. So from this point to that point, and I'll just draw here so that I can see 3.0. And then I'll go to the next 2 points. 1.5, and now the last 2 points. 1.6 or 7. So when I look at that, what I can do is I can now tell which one. I know that my smallest number is going to be common to run, and my next smallest number will be, or the middle number will be common to start. So that would make this point common and then this point run. So all I have left is, I know that run to start is going to be the largest number. And if you'll look, common to run and common to start almost equal start to run. Now, like I said, this is one that we use in the lab, so the numbers are bouncing or jumping a little bit, but that formula will always kind of play out true. They might not fall just exact, but they'll be very, very close to adding up. This might have been, you know, 1.8 or something like that, but you'll see where it falls and gets you right there. Depending on how you're holding your leads, if you're bouncing around or moving, you want to hold them on there long enough to get a good steady reading. But using that method, you can figure out which one of your terminals are common, start, or run. Thanks for tuning in to another edition of Toolbox Tuesday. We'll see you next time. Hey, we absolutely love our HVAC community. We want you to continue to tune in. We want you to continue to leave us your comments. Make sure you click below to subscribe. We definitely want to hear from you, and we'll see you next time.